Here we go. We're back for another college algebra video. This is section 8.4, systems of nonlinear equations in two variables. If you have not recently watched section 8.1, you may want to go back and watch the part 1 video of section 8.1 to refresh yourself about how to do substitution and addition as the two methods, because those are the same methods we're going to use in this section. In fact, this section has nothing new in it. By itself, it is a combination of putting together stuff from 8.1 and then some of the algebra skills that we had from chapter 1, solving quadratic equations, for example, that kind of stuff. Okay? So, as you will see, we'll look at ways to solve nonlinear systems using substitution or addition, either one. But unlike linear equations, sometimes you only have one option. Sometimes you can't use one method. Addition specifically is difficult to use sometimes, and we'll see what that looks like. Okay, so a system of nonlinear equations is containing one expression at least that is not in the form ax plus by equals c. So in other words, we've got a product of x and y, we've got x or y raised to other powers other than 1, that kind of thing. And because you have that setup, you have a lot more options. Okay, if you have two lines, you only have three options: infinitely many solutions, no solution, or one solution. But with a nonlinear system, you might have a couple of solutions. You might still have no solution, for example. But you have to kind of, just look through things and be very careful. Usually, you want to work with the more complicated or the nonlinear. If there is a linear equation, you want to work with the nonlinear first, if possible, to get all of your different possibilities for your variables. Okay, so we're going to walk through this first one together. We're going to use the substitution method to solve this equation. So how are we going to do that? Well, substituting x squared doesn't make any sense because there's an x there. I can't substitute x squared in for x. I don't want to be taking square roots because then you get a plus or minus. That's a mess. So what I'd rather do is I'd rather solve this for y. Okay, we're going to add 1 to both sides. So you get x squared plus 1 equals y. And then we can replace y with x squared plus 1 in that equation. Okay, make sure you group it properly. So you get 4x minus y. Y is x squared plus 1. And that equals negative 1. Distribute the negative, you get 4x minus x squared minus 1 equals minus 1. Add 1 to both sides, and you get 4x minus x squared equals 0. All right, this is a quadratic, but it has no constant term, so I can just pull the common x out and get x times 4 minus x equals 0. And this tells me that x equals 0 or x equals 4. So I get two values of x, but remember we're solving a system of equations. Systems don't have answers like x equals 0. What do systems answers look like? They look like ordered pairs. And these are both x's, which means we need the y's that go with these x's. So we need to take both of these y's, and bring them up and substitute in here to find y. So when x equals 0, we get 0 squared plus 1 equals 1. All right, so that's my y. When x equals 4, we get 4 squared plus 1, which is 16 plus 1, which is 17. And that's my y. So what do my actual answers look like? My solution, in this case my solutions, when x is 0, y is 1. And when x is 4, y is 17. So I have two answers, 2 points here. If you drew the graph of these two equations, all right, you would have this is a parabola, y equals x squared plus 1. This is a straight line, and so that line would be cutting through and hitting the parabola in 2 points. Right? Sketch it on your calculator if you want to double check and make sure that that makes sense. But that's what we have in this case, and so that's the process. So I want you guys to try this one. You know what the addition method is, and so or you should. And so I'd like you to try this one by the addition method. And pause the video now, and then we'll go over it when you're done. Okay, so there's a couple of ways to do the addition method, and obviously you could also do substitution here, but I'm going to do addition because I asked for it. I'm going to multiply everything here by -1 to change the signs. That gives me a -x minus 2y equals -4. And then I'm going to add these two together because x minus x is 0. However, notice here, these are not the same term, so they're not like terms. You can't add them. You just get y squared minus 2y. There's no way to combine those two. And then 12 minus 4 is 8. And so if I have y squared minus 2y, I'm going to subtract 8 from both sides to set it equal to 0 because it is a quadratic. This happens to factor into y minus 4y plus 2. And so y equals 4 is one possible y, and y equals -2 is the other possible y. And then I need to substitute back in to either of these equations, but you try to use the simplest one you can. And so x plus 2y equals 4 is the one we're going to use. So when we substitute back in, x plus 2y equals 4. Alright, so we substitute 4 in, we get x plus 8 equals 4. And so x equals -4. So when y equals 4, x equals -4, that gives us the point -4, 4. If we do this with y equals -2, we get x plus 2 times -2 equals 4. X minus 4 equals 4. Add 4 to both sides, you get x equals 8. And so we get the point 8 comma -2 as our other point. Make sure you get them in the right order, right? X goes first in the ordered pair, y goes second in the ordered pair. And these are my two solutions. Once again, I have a straight line and a parabola, and so they intersect in 2 points. It's possible that they intersect in 1 point. It's possible that they don't touch at all. But in this case, they intersect in 2 points, and so same idea. All right? So I'm going to give you another shot. This system, you get to choose the method. You've seen substitution, you've seen addition. You get to decide which method you prefer to use. In this case, this one is 2 ellipses, right? We haven't really talked about those in this class, but they are 2 ellipses that are being drawn, and so they could intersect in up to 4 different points. Make sure that you keep your algebra straight. Hit pause, give this one a shot. It'll take you a little while, and then come back and finish out the video. Okay, so I'm going to do addition again because these are all squareds. But I could also do substitution. In fact, if you wanted to do substitution, what would you have to do? You'd have to solve one of these. But when you solve, don't solve for y, solve for y squared, or solve for x squared, because you can plug in for x squared, because that's all you have, or you can plug in for y squared. So substitution would work if you only solve for x squared or y squared. Don't try to solve for y, that gets messy. Okay, but I'm going to do the addition method. I'm going to multiply the top by -3. I'm going to multiply the bottom by 2 and try to get rid of the y's. And so if we do that, I don't really have enough room over here. I think we'll come over here. We get -9x squared minus 6y squared equals -105. Use your calculator to help you with the arithmetic. You get 8x squared plus 6y squared equals 96. If we add these up, -9 plus 8 is -1x squared, 0y squared, and -9. And so if we divide both sides by the -1, we get x squared equals 9, so x equals what? Plus or minus 3. Don't forget, when you take the square root of both sides to solve for x, you end up with a plus or minus square root. And so x is plus or minus 3. We get 2 answers. All right, so now we have to check them out. So we're going to plug into one of these equations. So we're going to check out what happens when you do x equals +3. I'll use the top one. 3 times 3 squared plus 2y squared equals 35. 3 squared is 9 times 3 is 27. Subtract 27 from both sides to get 2y squared equals 8, and then we're going to divide both sides by 2 to get y squared equals 4. Square root both sides and get y equals plus or minus 2. Now, where did that come from? That came from x equals 3 only, which means we get 2 y values that go with the x value 3. Okay? Well, we're not done yet because we had 2 x values. So when x equals negative 3, we have to do this again, but when you square a negative, what happens? If you square a negative, you get a positive, which means this is 27 again. And so I'm just going to end up with same stuff, y equals plus or minus 2. And so I get another 2 values, negative 3, 2, and negative 3, negative 2. And so all of these guys, these two and these two, are 4 points that are part of my solution. And again, if you think about it, not that I'm a good drawer here, but if you draw ellipses that cross, in general, they're going to intersect in 4 places. And so having 4 points as an answer makes complete sense. Okay? So let's show you where you might be able to do an application here for this type of solution. So we've got a rectangle whose perimeter is 20 feet and whose area is 21 square feet. Draw your picture. You got a rectangle. We'll let x represent the length of the rectangle and y represent the width of the rectangle. Okay? So how do you find the perimeter of a rectangle? It's all the way around, x plus y plus x plus y. So 2x plus 2y is the perimeter. How much is that? That's supposed to be 20. And then whose area is 21 square feet? How do we do area? Area is length times width. X times y is 21. So here is your system of equations. Again, nonlinear because it's x times y. So the degree of that term is 2. That's why it's nonlinear. All right? And this is your system of equations. And once you set that up, you should be able to solve it. Okay? So step 3 is to solve the equations. And so you guys pause the video and do that for more practice. Come back, we'll finish out the problem. Okay? So in this case, this is an example of where you can't do addition. Addition will not work here because this is xy and this is 2y. They don't cancel out, and this is x. You can't do it. So we've got to do substitution. I'm going to substitute in for y, divide both sides by x, and you get y equals 21 over x. And then I'm going to substitute that in here. So I have 2x plus 2 times y. This is y. So drop it in, 21 over x. And that equals 20. So 2x plus 2 times 21 is 42 over x equals 20. And then you can't solve for x in the denominator, so I'm going to multiply everything by x so that I can get that out of the denominator. I get 2x squared plus 42, the x divides away, and then you're left with 20x on the right-hand side. And of course, we need to set that equal to 0 because it's a quadratic, so I subtract 20x from both sides. And I get 2x squared minus 20x plus 42 equals 0. There's a common factor of 2 here. Pull out the 2, get x squared minus 10x plus 21, and it turns out that factors. X minus 7, x minus 3 equals 0, and so x equals 7 or 3, one or the other. But guess what? When you go back and plug in, when x equals 7, y equals 21 over 7, which is 3. And when x equals 3, y equals 21 over 3, which is 7. And so while we have 2 different combinations, 7 and 3, 3 and 7 for a rectangle, it's really the same thing, right? So we have 3 feet by 7 feet is our rectangle. Those are the dimensions. It doesn't matter whether it's 3 feet long and 7 feet wide or 3 feet wide and 7 feet long. It doesn't really matter, right? So 3 by 7 is the dimensions of the rectangle, and that's all we were looking for. Okay? So practice that up and let me know if you have any questions. Thanks.